Welcome to Commocore Lab. In the last two videos I shown you unboxing, assembling and the first run of WiC64 wireless interface for Commodore 64. Thanks to this piece of hardware, within a few minutes I was able to go online with my Commodore 64 just by using Wi-Fi. In this video I'm going to show you the HTTP client I wrote with working examples. It simplifies development for anyone interested in usage of this device. Next to it, I will show you also JSON Parser library I used on top of it. Let's get technical. Okay, I'm going to show you WiC64 HTTP client in action. I have three examples for you. You can check it out because this repository is actually available online. I will put the link in the description. And now it's time to show you a few things. In order to do it, I will use this cartridge. This is Easy Flash 3 cartridge. I'm going to use it to communicate between PC, where I will compile my client and I will send it over to C64 immediately. And I have WiC64 already put into the user port. Okay, so let me switch to power off, and then USB is already attached to the PC. Let's attach it to the Easy Flash. Let's power on. Or should be just showing in a while. Okay, and now it's time to boot the cartridge and load the EF3 USB program. Okay, so program is loaded, and now it actually waits for command to be executed. So let's move to the screen where I'll show you the WiC64 client I wrote. This is an example which uses this library, which is just included here. So it's easy actually to send get HTTP the request, and using the examples of sending requests where I want to actually retrieve high scores for one of the games I finished recently, which is called Commodore X. So this is the page of this game with high scores, so you can see a little bit what's going on over here. We have a name of the user and a score and when it was submitted. So we're going to fetch this information using the WiC64 client right now. So you can see the function here. Let's go there, and the rest of the code over here is actually the client in action. So what we are doing, we are first of all, there is some mocked HTTP call I could use, but in this case I set it up to do a real thing, so we are not going to get a mocked response, but the real one. So this part is skipped with condition, and we're going to load the HTTP URL. HTTP URL, this is the address I'm going to use just to fetch the high scores from there. And then with this one, this is the first function which is available in the HTTP client to set the HTTP URL. So then, yeah, you can of course you can see what's inside, but this is already the implementation which was provided by documentation in WiC64, and this wrapper actually helps to make things easier for programming purposes. And yeah, the next thing is to switch WiC64 to send mode. We have to do it every time we are actually going to send any request. And then the call is happening. Then we are switching the WiC64 to receive mode, and from then on we are able to get the response. First byte, it's a dummy byte which we have to provide, and this one actually starts the IRQ at ESP module. So yeah, this is something which is in the documentation. We have to do it every time, but from then on we can get the response. So actually I'm taking the response length, high byte, then I'm taking the low byte of the response, which will display in this example. And there's some math I did just to extract the number and just convert it to decimal value, so it's easy to read on the screen. And then we are actually performing further actions, which are to read the error, if there's any error. If there's no error, then everything is fine and we are happy to continue, otherwise the program will stop. So in case there is no error, we are following, and then we are reading byte from WiC64, and there's like a loop which is working until the program will finish because of the length which we fetched. So this is the first kind of version. Let's see this in action, if we are going to see anything on the screen, and if everything will be fine, we should see the green border which indicates that everything went smoothly and the execution is succeeded. Okay, so I'm running and it already goes to easy flash. Yeah, and this is the response we already got from internet. So let's compare it. Greebly is the first score 4,4482, and then created just in August 24th. So that's the thing. This is how it works, and this is the JSON format actually, but in this case I'm not parsing it. So what if we would go further and try to parse it? I have an example for that. This is the second example. So this is HTTP call here, but the second one is for static JSON parsing. This one behaves the same way. It also takes the length and then reads until the end of the length, and then what the only difference is to make a static JSON parsing. This is done using my other library, which is called 6502 JSON Parser, and this one allows to set up this quite easily. So just to show it quickly, I have to declare which way I want to get this information. In this case I'm just setting the location of the object, which will be set under location 2000 hex, and then I'm switching to the parsing mode because this is actually something which we want to display on the screen. And then I'm setting two locations. One will go for players data and another for scores data. So here in the first one we'll have names, and in the second one the values. And then there's a loop. This loop actually goes around until all player and all scores are fetched, and if JSON object is not completed, then it will continue until it's over. So in case the player key will be found, it will just follow to store the JSON value in the player's table location, and then we'll offset for the next one plus 10. So the next location will be written 10 bytes later. Same for set scoring. Set score, we will get this value, and then the next value will be written 5 bytes after that. And that's pretty that. So let me show you that in action. Static one. Let's run. Earning is empty, and something went wrong. Not sure why, but yeah, I'm going to check it out. Let me try to do the third example. Maybe then I'll figure out what's going on with the second one, because actually this is something I didn't expect. So this third example is to make a streamed response, which means that the length of the response is actually ignored, because the JSON parser will fetch 1 byte, and when the object will be finished, it will stop fetching new bytes from internet. So let's see if this one works. I hope this one at least will work. No, it doesn't. Okay, so that's not good. Let's try to debug it then. Okay, so let's update the client. It has to take scores, then there's an object in an array for each player. They are sorted automatically by the highest score. So I have the previous version in the client, so I'm going to do the same as I did for Commodore X to update this repository with the current version. So here actually first of all I have to expect 4 scores key, and then only then I can go inside into setting the scores. Okay, and then I could use this one, and that's it. That should work. So actually I don't need this. So then it will go to scores, and then expects player and score, and when the JSON object is completed, then it will finish this one, but we'll check if the array is completed. In case it's completed, then it will go to another object, and if the whole array is completed, then it will exit. So let me try to compile it again. And nothing happened. Let's see what I did wrong. First of all, it needs to go to the scores when the scores is found. Oh, sorry, I did stream. No, actually, it should work for both cases. Okay, it works for this case. Maybe there's something else. Ah, yeah, because this is static JSON Parser. So as you see, it works for Gribbly. I can see the memory on the top, and then below I have this representation done this way. So let's also fix it for the other stream JSON. Alright, so again I will just expect the scores, and then I will go to set scores, and then when I will be there, I will check player score and I will check the player name, of course. So this is how the objects are interpreted by 6502 JSON Parser, and the code works the way that if the key will be found, it will go then to this iterator. This is how I call it, and then in the iterator it could be more nested, can go to another iterator in this case and store the value in the end. So this is how it works. So that was the example for static parsing, and let's check the last one for the streamed parsing. Let's execute, and it works. The length is 668 bytes and the answer contains all the information we need. So this one actually didn't try to check the length, but tried to get the response until the object wasn't finished, wasn't closed all the parentheses and all the curly brackets, which determines the valid JSON object. So that's all. I hope you enjoyed this technical video, and feel free to let me know what you think about WiC64 client, and if you're willing to buy this device and maybe also try to develop something. And anyways, see you in future. I'm going to probably to show you the Commodore game in action. Thanks for watching, and until the next time.